Okay, guys. It might be a bit harder to do all of this today because for some reason my Ubuntu is broken, and together with it's struggling with NVIDIA drivers and CUDA or whatnot, and because of that I only have a single screen today. So I'm just gonna grab this one, share it to the Discord. Okay. Let's go back to work. I might not be able to see your messages at all times. Let me just see. I'm gonna just leave this somewhere here, and I'll occasionally be checking the chat. Let me know if you can't see me or anything. Okay, we stopped at refactoring the Stopes code base. Let me see what was the last thing I've done. Let me just conda activate. Oops. Conda activate NLLB. Let me navigate to Stopes root. And let's continue where we stopped the last time, and that's we were modifying these scripts such that we can support the mined data as well. So I added this new section to the example YAML, and now we need to modify these scripts which are producing these configs. So let's go back to those scripts. We stopped here, I think, or let me see, actually here, I think. And I think I ran this already. Let me just double check. No, I did not. So we have to generate these new configs. Let me just think what we need to do here. So I'm just thinking whether we should have directions as a accumulation across primary and mined, or what. Let's try it like that, and then we can fix stuff if it's not working. So I'm gonna run this, and let's see what happens. So this is the extract directions and corpora. Let me just change the line. Okay. Do I need any arguments? No, I don't think I do. So I'm just going to put no arg config and run this. So we open up one. We opened up, we grab the data, we get to the corpora, and then, so we end up with a certain set of data sets, and this is primary. So we dump this file, and then we go all the way to here, and this will apparently not work because we have to accumulate all of the directions across the spectrum here. Let me just think for a second. Okay, let's just read a list. let's create a list of directions. So I'm gonna create like a new variable here. It's gonna be an empty like array, a list, and call it, oops, add a suffix list, and then we can just append to it this, and then at the end we want to merge. So we want to go and merge them together before we save them. I'm not sure whether this is going to work, but let's see. Let me see whether there is any messages here. I don't see any. Guys, if you have any issues, let me know. Okay. So we go, let's grab the keys. So keys are gonna be a combination exactly, and they're gonna be a set, and then to form the final object we'll have to go to the keys, create an empty dictionary, and then if key, let me see, we go through the keys and then we go through the exactly, and if key is inside there, then if key is not inside of here, we just assign it. Otherwise, if it's already there, we just add it, and then that's it. I think this looks good. I think this is the right logic. So by doing that, we will aggregate all of the, for all of the directions, we will add the number of sentences for that direction. I think this is not correct. Okay, let's rerun. Hit F5. Why is this so slow? This should be like super fast. Like I'm literally just doing, counting lines. Okay, fair enough. It's counting the lines. And then we extend the keys. And then we go through the keys. If key is present, then we do this. Okay, I think we're good there. And finally, that's it. We end up with something like this, which we can store, and that's it. Okay, will this now work? So I modified this code such that we create two separate configs for try primary and train mind, which basically contain the data sets from respectively from primary and mind data of our HBS data. And once we have those, then we go here and we build different included core YAMLs for primary and for mind, but we create a single one for direction. So that's the part that might be problematic. Let's see whether that's going to work. Will this work? Can I just have directions only here and expect that to work? Not sure, but we'll see. So included corporate, I'm going to delete this one. Here we have 6 of these and 89 of these. Can I? Okay, let me quickly see how many we had before. We had 95. Is that, if we sum up this, yes, 6 plus 89, 95. So we just now decoupled. We kind of decomposed this into 2 separate included corpora. That's good. That looks good. And now if we go to the filtering stage, let me see if anybody's writing anything. I don't see any messages, so all good there. Okay. Filtering, temporary. Let's just delete this output. Let's try and rerun filter. Let's make sure this makes sense. The logic I've implemented. Let's make sure it makes sense. Missing value, output directory. Oh, okay. Just a second. That's because I didn't pick the right config. Now I have. With the right launch JSON config, we can start stepping through the code. Okay, so we grab the directions. Well, I could easily create 2 separate direction files as well. Well, let's see, do we need to do it? So open all 5 directions here. Included corpora. So we'll have to modify this code, definitely. This was kind of hacky beforehand. We need to do the same thing for train mind, right? So let's do it. Let's stop this. Can we do something like if it's not none? Yes, if it's not none, then we grab it, open it up, and then update with the corpora. Okay, this looks good now. And we can just repeat the same logic for train back translated train BT. If it's not none, grab it, load it, and update. And that's it. So we are expecting that this exists. We need to assert that is not none. Okay, looking good, guys. Let's rerun. No such file. Included corpora primary. Aha. Okay, that's because I didn't specify the right paths here. Primary included corpora. And mind. Save this. Rerun. Looking good. Awesome. That's great. So now we go through the old directions. We set the directions, we set the output directory, and then we go through the groups. So that means we will pass for train primary, we will have all directions, and also for train mind. But what if some of these two doesn't have all of the directions? That's my concern. And that's a legit concern. Get the config. Load the datasets. And then if direction is not in the directions, we continue. Okay. Aha, aha, aha. Okay, so I think this will actually handle it properly. So, included corpora. So we go through these, we get the direction, and okay, it's actually gonna be good, because if for some reason so bottom line, config directions only serves to, it serves a simple purpose, and that's to exclude directions which are not supported there. But if let's say mind doesn't support it a certain direction, then we will not have that iteration here. So I think we're good here. Just think for a second. If we didn't have this direction, then we would simply omit it and we wouldn't have that iteration of the for loop. Okay, we're good, guys. This actually works. So I'm gonna stop here. See what to-dos I have left in this file. Okay, so now we can implement the correct solution. Instead of having the extra filters, we will just include it because we know we are dealing with mind data. Okay. So if this equals train mind, in that case we append to the filters list whoops. We just append filters, append this guy. Let me just think whether this one should be somewhere in the beginning. So we need to just insert it somewhere instead of doing this appending logic. And then we can remove this. And we can remove this. Let's see how we can insert. Okay. Let's just insert at position 2 this guy. So we want to have laser, which is almost always no up for us, length filtering, symbols filtering, so I think we need to insert at position 3. And that should be it. This is the fuzzy deduplication logic, which is not that good at the moment because we have to load into RAM all of the lines before we can instantiate the filter. We'll probably have to change the logic altogether. Okay, let's quickly test this. I'm gonna put train mind as the first one, and then train primary, just to first test that this makes sense. Hit run. Okay, so we have 1, 2, 3, 4, 5, 6, 7 filters. And then we want to insert at a position 3, so ideally after symbols. Wait, what? Aha. Wait. I'm gonna stop this. Let's rerun. Aha. Okay, so I made a mistake here. Because I tried to do it here, but we are actually running this code here, so. Okay. Now let's rerun. Okay, that looks good. Length symbols mind. Looking good. And here is how our config looks like. Everything is null here. This is null, this is null, this is null explicitly. Symbols is not null, hence we use the default value. And then there is the mind filter, which is also not set. So that means it assumes a default value. Okay. I think this is not correct. Let's start refactoring the rest of the code base. There's a ton of new YAML files. Let's see the mind and symbols implementation. Symbols. So this is the implementation of the symbols. Hey Aditya, we are trying to... I'm just refactoring the code currently. I'm adding some new filters so as to have higher quality data sets. Viral corpora needs to be filtered before we can run the training. Non-printing characters, Unicode, punctuation. Okay. So with all of this here, by the way, I keep copy pasting the same code. It would be cool if we could just import all of that instead of having to copy paste it. That's the first part I want to fix quickly. Text normalizer. Let's just import from this text normalizer. Like that. Go back here. Do we actually need any of this? Okay, looking better. Digit to character ratio function. So get digit to character ratio, takes the line, removes the punctuation, and by punctuation they mean Unicode punctuation. And then we go and find the digits and find the alpha. Although I'm still thinking, do we need to do this? Because this will not affect the digit and this will not affect the alpha. So I think we can just do it like this. Get ratio of words with alpha. Then we split to get the words. Then we go through the words, and if it has the alpha character, and then we have the ratio, okay? Detect ellipsis, replace the Unicode, And then currently we're detecting not the ellipsis per se, we are detecting 6 dots or more. What do we want to accomplish using that one? I don't think we have to use this one for now. I'm just going to put 3 here because that's the ellipsis definition. And then let's see how we implement this filter. So symbols filter. I think we will be able to, let me think for a second. Nah, it's good. I wanted to maybe merge symbols with that mind filter, which just basically captures the dates. Maybe we can do it. So instead of having mind and this one, because this is a fairly simple one, why not just grab this, go to symbols, store the patterns, filter, keep dates, by default it's going to be set to true, dates and numbers patterns. Keep dates and numbers. Store it. Exactly. And then only if this is set to true, actually if it's set to false, if we don't want to keep them, in that case, we do this. And that's how we merge 2 filters together. Okay, let's see. Cache tag, digit to character, words with alpha, ratio. Keep dates, debug, patterns. If debug set to true, we just have symbols txt. Okay, debug symbols txt. And let me see what else. This should definitely be outside as well. Not the class function, but instead independent function. So what it does, again, replaces the Unicode punctuation, sets the flag to false. If the line starts with quotation mark, but doesn't end with one, in that case, we remove that quotation mark and set the flag to true. And also for the other case where it doesn't start with quotation mark, but it ends with quotation mark. Then we remove the last quotation mark and set the flag to true. Okay, fair enough. Now let's go to the actual filtering function. It's kind of a mess because I keep on repeating the logic multiple times. So I'm just going to remove this and then do a for loop for line in line target. Do something like this. Line count. Okay, this is much neater now than it used to be. We renamed these functions, so let's just update the names. Okay, so let's see the logic. We go through the lines for the source and target. We see how many hashtags it's got. If it's bigger than this number, if it exists and it's bigger than this number, then we remove this pair altogether. Additionally, if debug is set to true, I'm going to call this current line just to avoid the confusion. Okay, so we go for current line, count the hashtags, and then just store them here. Okay. Secondly, if for the current line this ratio is bigger than what we specified, too many digits, then again we remove. If the ratio of words with alpha is too small, in that case again we remove the line. And finally, I'm gonna comment out this one for now. Additionally here, if we don't want to keep it, then we go through the patterns, and if it exists inside of if the pattern exists, then we remove the pair altogether as well, and we again just save if debug is on. So that's all good and nice. Okay, that's it. And as for this function, balance quotation marks. Let me think for a second. I think we just want to modify. We want to modify the lines, nothing else. Okay, remove the self. What do we want to do here? I'm thinking the symbols filter. Let's go back quickly to the filters. So symbols comes after laser, which we never use, and length. And then comes symbols. And before we even apply the filters, we also have options to modify the line. We can normalize the Unicode, and we can normalize the punctuation. I think we set this to true. Yes, this is set to true. We always normalize the punctuation. We don't call normalize Unicode. But we might want to non-printable characters. Where are those? Okay, remove non-printing characters. Is this used anywhere other than in this file? Where does one call this function? This is a dedicated normalize different function. Okay, I don't see this one used anywhere. So again, it's defined. It's defined here, but I don't see it being used anywhere. Okay. Yeah, I think it's safe to go back to the filter.py and address this to do non-printing character removal. We should normalize our lines. Let's add that function here. Once again, let's see what they all do. So we don't want to do this, we don't want to do this, we don't want to do this. We do want to replace the Unicode punctuation and remove the non-printing characters. Okay. And strip as well. We want to strip as well. Just think for a second. We literally open up the raw data here. So that means we've never done any processing of our lines. Having said that, we definitely want to strip before we go to the filtering stage. So maybe instead of specifying normalized punctuation, let's rename this one or do something with it. Okay, let's go back to filter config. Let's modify this so that we have okay, let's maybe add normalize let's just call it normalize line. Save that. If normalize line. Hi Frank, thank you. Let me remove this. Again, we'll have to now, instead of normalize punctuation, we have to change this to this. And normalize line will do the following. We grab the line. We first strip it. Then we replace the Unicode, and then we remove non-printing. And then return the line. That's it. Okay, that looks better. Maybe it might be worth to Just see when they differ, how often this happens. I'm gonna put a breakpoint there just to test this. But guys, I think we're making some progress. On 4.5 hours of sleep, I'm doing quite well. So balance the quotation marks. Do we want to do this? I mean, this is something we always want to do, so really this should be a part of normalized line. Go back to symbols. Remove all of this. And we are done. That's it. That's the symbols implementation. You can remove this hanging import. And we can remove the mind file altogether. And that means we can go here and instead of doing this, we want to modify the filter here such that this is set to should we keep it? We should keep it if you're different than mind. You should keep it if this is different than this. Otherwise, we don't want to keep it. Okay, that's much better. Okay. Let's run this. Put a breakpoint here. And kick off the run. Forgot to delete that one because we removed the mind filter. Division by 0. Oh my god. oldest error in the book. I fell for it. So if the character number is 0, in that case, is this even good logic? So digit to character ratio is set to, I think, 0.9, no, 0.5 at the moment. And so this can go from 0 to infinity at the moment. This function returns from 0 to infinity. If 0 digits, then 0. If all digits, no characters, then infinite. I ideally want to normalize that from 0 to 1. To make that happen, we have to do what? How do we want to implement this? Just a second, let me think. There's a ton of weird edge cases here because most of the characters sometimes won't be neither one of these two. So if we assume we only have alpha and digits, in that case, again, the edge case is all digits, no characters. I mean, we can just do something like this. So in case we have all digits, then the ratio is just the digits count instead of infinity. Okay, this should be good. Let's rerun. Let's just see when we hit this branch here. I also want to handle, we have to pass in the debug argument to these filters. Okay, here it is. Line. And of course, we won't be able to see the difference. Let me see if there is any difference between the lengths. So line, the original one, versus the process one. Okay, there is one character that's missing. Aha. Doesn't happen all too often. But that's it. Okay. Getting back here. Let's see what we have left to refactor. Let's go to configs.py. See what's the difference. So we've added the symbols filter config, fuzzy dedupe filter config, and mind. We don't need this one anymore. So here are some changes. I renamed this variable. I've set all of them to have default instead of none. All of them are optional except for the symbols and length. Okay. Okay, all of this is good. As for the default value for the symbols, let's see. Yeah, you have to specify it. Okay, I'll just leave it as it is. It's good enough. Let's go to filter.py now. So I'm just going top to bottom and making sure all files are of decent quality. Filter.py, let's see what's the difference here. Again, we have this normalization. I don't like this one. We have to fix this. This is fine. This is fine. This is fine. This is hacky, but it's fine. And all of this is fine as well. So like we have to fix fuzzy deduplication. Fair enough. Let's go. Let's continue. Let's go to init. Filters init. Okay. We might not need HBS. I was kind of experimenting a bit with the HBS. Yeah, let's leave it for now. Don't want to overthink there too much. Let's go to base, filters base. What did I change here? Oh, okay, I've added the symbols for the symbols filter and the pair fuzzy dedupe. So that tells us the reason why the sentence was filtered out. And this is good as well. Okay, that was base. Let's go to dedupe, LID, and toxicity. And then we have these two. We can ignore prepare data. I haven't been touching those. So let's maybe start with extract directions and corpora and populate data config. I think those are good already. I commented out this, I renamed this one, and then I just reused for both train mind and train primary that function. And we can just go back here like this. That's good. And finally this file. Okay, I made a couple of changes here. Okay, that's good enough. And as I said, lastly, these three are something I have to fix. Maybe before that, let's see the symbols. Okay, symbols we already fixed actually. So I'm just left with 3 new files. Dedupe, LID, and toxicity. Those need to be revised. Let's see, what did I change here? Okay, we have this logic for dumping for debugging purposes. Let's make it nice and similar design as in symbols. So this is the design we want to have. Let me see whether somebody's commenting. All good. Toxic sentences counter. Yeah, we don't need that one. So we just need to do this. And after this, let's just set debug here. By default, it's going to be false. Same as up here. We don't need this. And now let's go to symbols. This is the logic we want to have. So if the difference goes above a certain max threshold, and if the bug is toggled on, we save again those two sentences and we flush. That's it. Okay, that's it. That's all we need there. Next up, LID. So I've added a brand new HBS LED filter. Replace Unicode. Let's see what the logic looks like. I think it's mostly the same as the thing we have above here. We just additionally have again this logic. I'm gonna just copy paste, have the same design across the board. Exactly. So we want to have a normalization. What does the normalization do? In the case of LID, we want to grab a line. We want to strip it first. And then, not sure whether this lower does it in place or it retrieves back the result. And finally replace the, just to make it a bit more readable. Let me see for the lower. Python string. Does it work in place or what? Well, we can quickly test that. Let's see whether this modifies it in place. It does not. So we have to return back the result. So lower, return back, and then so we strip, we lower, and then replace Unicode. Okay, so here I'm allowing myself some space, some flexibility to potentially add certain heuristics for HBS languages, exploiting the domain knowledge, like the fact that Bosnian might have a bit more Turkish and German in the data set. LID L and P, LID probs. Okay, this is what I've added. But I haven't been using it. I think this is the same code as above. 15 lines there. Or is it? I've added the debugging part. Okay. So for that, let's just replicate what we have done in the previous filters. And that's this. If debug is toggled on, in that case, we do something like this. And same here. Let's maybe move this one down below. And we need to do the same thing here. Okay. That's it, nothing super smart there. We just allowed ourselves to have additional flexibility if we needed. And the last one is dedupe. So I think I've just added a fuzzy one, that's it. Yes, so we've added the fuzzy logic here. And this is something we'll have to fix. Let me just see what else we have. So I'm almost done with this. Wrap up the fuzzy and kick off the filtering run. How will we know which data labels to apply later on? That's an additional question I have. So wrap up this, and then kick off the run. Let me think for a second. Currently, when we kick off the filtering run, we end up with something like this, train primary. I guess we'll just have train primary and train mind. Let me just see for a second. Go back to filter. Where is that determined? The output directory or the filter direction, filter group. Output directory is set as whatever is in config. Let me just see how that one is used. Apparently it's not used. Huh. Okay, this could speed up things. There is an issue though. If we want to do this, the duplication will be difficult if we have multi-process. Okay, I'm gonna think about it later. Okay, this is how we end up having the group name. So this will handle everything. So we don't have to think about this part. After filtering, we'll know exactly where each of these buckets is stored. Mined, public, and back translated. And then we can use that. And this is a question for the prepared data, actually. Okay, there's some issues with, hopefully you guys can still see me. Let me know in the chat if there is any issues. Go back to dedupe. Let's kind of refactor this code and let's fix fuzzy and we can start running our first jobs. And see how much data we filter out. We can fine tune the parameters so that we have roughly the target number of sentences that we need. Okay. So we definitely need to expose the VNR here. I'm fairly sure this is the order VNR, params are bands and size of each band. Okay, looking good. We can maybe go to config and specify this. Remove the commas, that's not part of the syntax. So again, we go through the lines, we strip them, we shingle them, and we encode it, and then we insert it. Okay. simple logic here. And the filter line does what? Correctly way to pass in the line number in order not to break the function signature. Okay. So this is to increase the recall. We want to do some normalization as well. Okay, let's define normalize here as well. We are applying these multiple times. I'm not sure whether this can slow us down. So text is lowercase. Punctuation is removed. Let's go and grab that. So normalize for dedupe. We can have like a normalize for fuzzy dedupe now. Or we can just use the same thing. This is pretty much it, right? If we go back, let me just go here. Let me copy this one. Let me open up the dedupe. Here it is. So we normalize it before joining. And again, lowercase, we've done that. Punctuation is removed, we've done that. Stripping, lowercasing. We might want to do also NFT Unicode normalization. Accents are removed. Not sure what they mean by all white space is normalized. Okay, you need the code. Okay. I think this should do it, plus just add a bit of modification here. If this is set, then we want to do... there's strip accents here. So it does normalization using NFD, and then for character in NFD, if the category of the character is different than this, what does this mean? Let me see whether people are asking questions. I don't see a question. Okay. So accent character has the category MN. Got it. Okay. Let me just ask ChatGPT something here. Let's ask it. non-spacing mark. Wow, nice. Nice. The code snippet references the Unicode data category function from the Unicode data module. It returns a 2-letter string that represents the general category of the character in the Unicode standard. So there is the L category, uppercase, lowercase, title case, used for a digraph 2-letter sequence which has a single letter as its uppercase form. Non-spacing marks, spacing combining marks, enclosing marks, connectors, dashes, math symbols, currency symbols, space separators. Okay, now it all makes sense. So this will retrieve us back if the length is the same. Then just return back the original line, otherwise join. So this strips the accents. Let me just see what this function does. What is \r carried return, or no, this is not the carried return. Carried return, that's the non-printed character as well, right? Let's see what ChatGPT tells us here. Okay, they pretty much serve the same. That's what I thought. So remove the carried return, remove the extra spaces. This is some punctuation, I guess. Removal. Okay. So ultimately what I want to do is just add accent removal and Unicode normalization. Let me see where we are using the, so this one is using strip accents and here as well. Okay. GPT. Normalization form D, decomposed. We're asking Python to decompose the string into its canonical decomposition, into their individual components, as a single code point, which is Latin small letter with acute, whereas a combination of the letter E and its acute accent. They both display the same thing, but the underlying sequence of code points is different. Okay, makes sense. So this is the decompose, normalize, decompose. Normalization form decomposed. Okay. And we just remove the accents. So we've done this now. And then there is the all white spaces are normalized. What exactly is meant by that? What is meant by normalize white space? Okay, so we replace this with this. Okay. Will this convert tabs into space as well? I guess it will. S plus should do it. Nice. So for fuzzy, we just add this additionally. Although, come to think of it, why not just yeah, I think we should just do this always. And just remove this. We don't need to do this. Okay. Looking good. So we normalize those two. We create a new MinHash. We shingle this. Then why not? Wait, source line. And same here. And then just repeat the same process all over again right here. Maybe a bit more succinctly. So same logic up here. And then we query. Okay, so now this is where the problems start. We need to find these equivalence classes. Let me see what I've changed here. I've added normalize white space. Because of that, I removed stripping and this tab thingy. So these two are captured in normalized white space, and I additionally added strip accents. That cannot hurt us, that's gonna be good. So like if we're doing exact deduplication, we still want to catch, like if we had a word with diacritics and the one without it, we still wanna exclude those directly in the exact deduplication logic. So this is good. All of this makes sense. We are almost at the end. We just need to make sure that the fuzzy is working properly. We refactor the code as well. This is the last thing we have to do, and then kick off a filtering job and just experiment a bit to see how aggressively are we filtering. Let me see if somebody's asking questions. All good there. Okay, so now for the issue. We can't use this logic to filter. We can't use this logic to filter their candidate duplicates, because the recall is never going to be 100% with fuzzy, and because of that we cannot rely on lines such as this one. So we ultimately have to construct an equivalence class Let me ping Chris, maybe ask him if he has any code. Okay, short break before this last task, just to stretch the legs and refresh a bit, and then I'll be back in a couple of minutes. Make a short break, like maybe 5-minute stretching break. Stretching break. Okay, guys. Catch you soon. Okay guys, I'm back. Am I using, good morning, yes, David. Am I using NVLink with dual RTX? No, I'm not. I don't think it's useful at all to use it in such a small setup with RTX 3090. I think if you take a look at like Team Detmers had a nice blog on that topic, PC or something. I think he mentioned NVLink in one of his blogs. Let me quickly see. Check out this. It's useful if you have a cluster with 128 GPUs or something. Otherwise, you'll yield almost no benefits over standard PCI transfers. So check out some of these blogs. That's going to be a good reply to your question. Okay. Back to here. Let me see whether... Okay, how can we merge candidates using data sketch? Well, let me think. I might have an easy way to solve this without doing any of this. Why not? Why not just no, the issue here is we have to do this. We have to do this on the fly with the current logic in the filter.py, but we actually need to do this offline. So that's the ultimate problem here. We are applying these filters right in here, when in reality, what we need to do is somehow integrate into, modify this whole process such that we can do additional paths using fuzzy. So we need to comment out fuzzy. Either way, fuzzy should go after exact dedupe, but basically this should not be in here. F out source and target. In the next iteration, we should do fuzzy deduplication. Okay, let's see how we can do this, guys. So dataset count, total before, total after, and then we save it, and then we do the same thing just with fuzzy. So what can we do here? Again, this is doing deduplication on a dataset level. for a particular direction or particular data set. How can we modify this code? If we exit and then repeat the process, can we keep the datasets count? I think we can, because it's here, specified here. So we can just leave this. Okay, let's do something like this, guys. Datasets count. We can remove this as well then. Fuzzy dedupe. Remove this as well. All those are just residues of the fuzzy deduplication attempts. Okay. So now I just removed the fuzzy deduplication from that loop. And now we need to see how we can integrate it back into it. So what's the best way to do this? Why not? The issue is with these counts. I can always total after, and then we start with total after, And then we can have something like total after fuzzy deduplication or something. Okay, so maybe if we modify this to additionally have exactly. Now let's go back to the filter. Dataset counts, corpus name specified up there, counts is specified above, path counts is specified above as well. Okay, so we can do this. We can just postpone this. Put it in here. So it needs to be in here. It doesn't really matter whether we do it inside of this context or not, right? This doesn't change anything, this. And now what we could do is repeat the same process. Huh. Okay. Let's see what's the most elegant way to do this, guys. Instead of saving this, why not just keep it? We might have memory issues though. I'm not sure how this dataset reader is implemented. Maybe it's implemented as like a memory map. So we read from a data set which is what? It's just a, okay, it's a data class. Just a ton of paths, nothing special there. So again, we pass in the string, which is a corpus name, and this data class into the dataset reader. And then we reiterate TSV path. The only thing we pass in is the data stat. We don't have the TSV path, so we will not do this. We will only do this. We'll open up this and this as a read. So we just basically do this. We can replicate this easily. We open those files in a RT mode. I'm not sure. This is read text mode. And then we enter this branch during the iteration. where we just go through the files and we yield a dataset line, check offset for the index, if line offset start specified, which it's not, because we just have dataset and corpus being passed in. So in that case, we just have yield. And because we have yield, and we are in this branch, we just retrieve back this. Okay, this is just a fancy wrapper that we can easily implement ourselves. So nothing fancy. I thought maybe there's something a bit more complicated in there going on, but not really, which is good. So that means we start from, well, let's kick it off. Let's quickly kick it off and see the paths. But this is raw data. And then we write to gzip. Okay, I think we'll be able to solve this. As you can see here, source is just directly points to this textual file. This is not gzip. And then the output is going to be gzip. Okay, but we know that we don't want to write this just yet. Instead of doing that, we want to repeat the process with fuzzy deduplication. Okay. Well, then what we need to do is this. Don't do this just yet here. Do it a bit later, outside of the for loop. And here we just collect the lines. Source lines. Like output source lines, gonna be empty initially. And same for the target. And instead of writing, we just append. And same here. Okay. So this is now completely equivalent. We just need to write to the file once we are finished. But before that, we need to implement fuzzy. Okay. So let's do that. Fuzzy is gonna be, it's gonna have the following interface. So we pass in we just pass in the lines. And after that, and we also need to pass in the dataset counts. And after that, we just need to go exactly and exactly. That's it. And finally, we save the dataset count. Okay, that's how we're gonna do it. Process, and then once we have the lines, that's when we go and do fuzzy. Now, this might cause us some memory issues, right? Because previously we were just reading one line after another. This might be a bit suboptimal. Let me stop this. So here we read line by line from the file, as opposed to having everything in memory. But here we are bloating our memory requirements by doing this append operation. But for fuzzy, let me see. Why not label that as temporary? And then in the next iteration, we can form the final file. Not sure what's the best way to implement this, honestly, but let's think step by step. Yeah, unless you have a ton of GPUs, I don't think it's going to be worth it. Okay. How is this going to look like from the memory standpoint? Okay, let's for now just create this, make this a no-op. Let's comment out everything here and just implement a no-op. Just return like this, and let's delete this temporary output. Let's go to the example YAML. Let's toggle on all of the filters and see how much data are we going to filter out. Just as a test. Laser, we're not going to use laser. This is fine. Symbols, let's see how to specify symbols. Let me just put this on the right. For the symbols filter, let's just use the defaults. Or Or better yet, let's just specify the relevant pieces. Here. Repeat that same thing down below with mind. Okay, so we have the length filter, the symbols filter. Next up is what the, save this, open up the filter. The LID filter. Default threshold 0.9. Toxicity filter. Like this. Let's just repeat the same process down below. Then there is the fuzzy, which we're not going to use. And there is this one. Dedupe. Let's see how many lines are we're gonna be left with after we are done with this. So LID, toxicity, and dedupe. That's it. Let's just make the output be named test. Output directory should be named temporary. Go to filtering, temporary, and then just suffix additionally test. Creative naming is super important. Okay. So with this, we've got ourselves a pipeline for filtering. We'll be filtering based on length. This is reasonable. This might need some tweaking, but whatever. LID, toxicity. Okay, I think we're good. I just want to now see what do we get as the result. How many lines? I'm gonna kick it off and hope for the best. Lol. Let me just quickly see what did I do with fuzzy. Okay, this is currently not used, so all good there. Kick off the filtering run. And run this. Okay, let's specify these in the config. So go to the configs, symbols. Okay, looking good. Is there anything else I'll have to add? Let's just kick it off again. Stop this and rerun. Let's see. Is there any other issue? So the memory will likely be increasing heavily because we have 3 dataset run. We'll have 3 directions, actually even more. Just a second, actually have to stop this quickly. I made a small mistake. Again, delete this. The only directions we're gonna care about is, we don't care about Bosnian here, and we won't care about Serbian, Latin. So Croatian and Bosnian Latin script and Serbian Cyrillic script. That's it for the directions. Here are the data sets. And that's it. So now, let me think for a second. Let's see how big those are quickly. How big are those? So if we go to, let's see how big the whole thing is. So this is 10 gigabytes primary. This is going to be way bigger. 30. So that's 40 gigabytes of data. But we are not going to use everything. We're going to use only a fraction of that because we ignored these 74 million here. So we might be using like 30 or something. And then additionally, because we're filtering, we will not be keeping all of those in memory, only the ones that pass the filtering. So I might expect maybe 25 gigabytes, let's say, if we're worst case. So like I'm 12, I have 64. So I think we should be able to run this without any issues of failures down the road. So let's kick it off and see how it goes. Let's just keep a track. Let's keep an eye on this output here. Train primary. Okay. Let me just update people in the server. And then LID. And then what else we have? We have the exact duplication. And there is also toxicity lists. Okay. Okay. That's it. It seems we are running successfully. Let's see how we are progressing. Wow, we're filtering a lot of content. Okay, let's just leave it be, and we'll see what's the distribution later on across these various filters, which filter is filtering the most, etc. Aditya asks, how can you start replicating papers if you have done some amount of deep learning? Start by analyzing other people's projects and tweaking stuff, playing, learning, and then depends how much time you want to spend. You can use multiple different projects and try and mix up all of those and create your own, or you can start from an existing project and then build up from there. Like, there's a ton of things you could do. I don't have a straightforward answer to that question. It's a spectrum. It can take anywhere from a week to like 3 months or more, depending on how much you want to constrain yourself. Okay, let's see what else. In the background, I can probably start implementing the fuzzy. I kicked off a preliminary run, and then later we're going to start preparing the data, and then we can kick off the run. Okay. Let's go and play with fuzzy. Let me just quickly see what's going on with memory. So, assuming we don't have any memory issues, the easiest implementation is to, okay, we don't need this anymore. Because we have the lines. The lines have been processed and saved. So we just need to iterate through the filters and through the lines. Okay, let's create that filter. Like that. Grab the lines. And that's the filter. So now that we have the filter, we go through the lines. We don't need to normalize it. We need to form a dataset line. And then we need to filter that line. First line is going to be like this. As I said, this is going to be a bit hacky. Okay, so we instantiate the filter, we go through the lines, we add the index information to the source line, then we create a dataset line, we pass it to the filter, and once we are done, if it's none, then we break. If it's none, then we continue. If it's none, we just continue. Otherwise, we append. Otherwise, let's see the logic here. There's the fuzzy thingy we added. Total after fuzzy. That one needs to be incremented. And we save stuff because this is not used. Actually, it is. Okay, let's just then keep appending the lines here. This is gonna bump up the memory even more. This is an error, obviously, because let's rename that. And now this is fine, but I have to obviously create the empty list in the beginning here. And same here. And then we return back those. Okay. Getting there, not quite, but getting there. So what's the issue here? Again, the fuzzy filter logic is still not perfect. We have to keep a track of actually what we need to do is just pull this, don't do that, and then go here, and then filter needs to be modified a bit such that it contains some information about the pairs that we want to remove. I mean, this can be improved and I will improve it, but for now, I'm gonna create a to remove set, and then we do what? Does this filter line, by the way, has to conform to a particular format? I guess we have to return a value. Optional, okay. We optionally need to return the dataset line. That's cool. So we don't have to do it. So fuzzy dedupe. We go through the results now. And we go through, let's see, if I is into remove, we just continue maybe, or return. Otherwise, so we go through the results and we just keep a single candidate. Will that work? So if we go through like for I in range 1 through length of result, we add result of I. Will this work? I'm not sure if this is actually correct implementation. Logically, this is actually gonna do what we need to do, because what happens if, trying to think of failure cases here. I can just submit some solution and then iterate with others. I don't have to do everything on my own. Let's say we hit the first line, we find the candidates, we label them, then we hit the second line. And let's assume let's assume that that second line has among its candidates line number 1. If that's the case, then we still keep the line 2, but we add the line 1 to the toRemove set, which is actually fine. But what happens if line 1 is actually a fuzzy duplicate, but it's not mentioned? In that case, we'll have both 1 and 2 surviving, quote unquote. So it might happen that we do not remove, with this implementation, I'm fairly sure that we will not be removing all the duplicates. Okay, just a second, guys. Okay. And then I'm thinking, what if down the line, maybe line 30? So like, when we get to line 30, there's a couple of situations. One is, line 1 is not a candidate line. In that case, all is good. We will not be adding it to the toRemove set. If it is, then we have two options. It's captured among the candidate pool, or it's not captured among the candidate pool. If it's captured, we will remove it, and now this line 34 will be instead saved. But if we don't capture it, in those situations, we will be keeping both candidates. So even though this is gonna work, it's not like, but it will not be perfect. We could do better than this. Having said that, this is the easiest implementation I can think of without having to create some types of connected components. I'm not sure why data sketch library didn't, like, this is kind of one of the most obvious things that you will need when you're dealing with these types of probabilistic LSH types of algorithms. So I'm not quite sure why they didn't cover that. Huh. Union find. Yeah, I think this is what I'm trying to do. It looks like, at least. Okay, let's see. Let's read this block, guys. We found pairs of near duplicates text in Azuna job salary predictions Kaggle competition. But many pairs will be part of the same group. In an extreme case, there could be a group of 5 job ads with identical text which produces 10 pairs. Both for interpretability and usability, it makes sense to extract these groups from the pairs. Okay. But many pairs will be parts of the same group. I'm not sure what this means, but let's continue. Each band of the LSH consists of buckets of items that might be similar. You could view the buckets as a partition of the corpus of all documents. We then need to find the finest partition such that if 2 elements are in any subpartition, then they are in the biggest partition. The algorithm for joining these disjoint sets is called union find. The idea is simple. Each element contains a pointer to a parent element. There is one element that contains a pointer to itself, which is called the root element. A partition is all elements that point to the same root element. Then finding a partition means walking up to the parents, to the root. Unioning 2 partitions just means setting the root of one to the other. Implementing this in Python, keeping track of the parents in a separate dictionary. Okay, implement this in Python. For large sets, these root structures can get quite big, and it makes sense to compress or somehow shorten the paths by repointing them to ancestors. I won't worry about that here. Here's a convenience method to get all the partitions from the parents dictionary. Combining the LSH with union find. Let's see. We insert. And then later we have the hash tables, okay. We go through the hash table items. And then we call union. We pass in the parents. There is a way to view this from a graph point of view. We consider each add as a node and each pair as an edge on the graph. Then we want to find the connected components of the graph. This will yield the same groups as union find. This is straightforward with network X. Aha. Underneath, this works by a breadth first search, which is effectively similar to union find, just going in multiple directions instead of up a single tree. Okay. Okay, guys, let's continue this in the second stream. Let's make a short break of maybe 40 minutes, and then we can continue in the second stream going through this code to see where we can improve this existing implementation of policy deduplication. Okay, with that, I'm gonna log out, guys, and catch you in the next one. Cheers, guys. Hello, man. I didn't see your message. Let's catch up a bit later in the second stream.